Hey everybody, this is Larry. This is day 30th of the LeetCode Day Challenge. Boo! What is today's problem? Number of longest increasing subsequence. Hit the like button, hit the subscribe button, join me in Discord, and let me know what you think. Okay. So this is gonna be dynamic programming. That's just like how longest increasing subsequence work. There, hmm, So there is a n square algorithm, and you can actually reduce that to n log n. Um, and I'm trying to think whether for n is equal to 2000 is fast enough. I'm going to do it the n square way, and then if it's fast enough, then we'll just leave it at that. If not, I'll upsolve it to or right solve it to n log n. But the idea behind the dynamic programming solution, and usually I do this top down, but n squared at 2000 is going to be cutting a little bit close. But the idea behind it is that the state, what is the state for the dynamic programming, right? Well, is that 4, well, we look at every previous number before 4, say, and then, well, every number that it is bigger than that number, is it increasing? Okay, so it's monotonically, it's not strictly increasing. What I mean by that is just like the tie-breaking rules for like the same numbers. So 4 is bigger than 3, so then we just add 4 to the longest sequence that is connected to 3 and 1 and so forth, and then take the max of that, right? So that's kind of the idea that I'm playing with. It's something that comes up a bit, and it's also kind of a longest path in the DAG type of dynamic programming, where you could in theory draw edges between for every node and the previous edge, and then try to find the longest path in that, and then also do some kind of count. So let's kind of do it that way. We'll do it the n square way, and if it gets to it, I will do the n log n way. So the n log n is actually a little bit tricky, but yeah, based off that, let's get started. Let's just say, how do I want to? I always struggle with variable names, so I'm going to write best ending on index, or longest ending on index, and count ending on index. So this is just an array of times n and times n, something like that, right? And I actually like to usually do n plus 1 so that we could save the zero index for basically the number that's before the first number, right? Because then now I can do something like count of a lot of typing on this one. Count of 0 is equal to 1, longest ending on index 0 is equal to 1. So you can kind of figure out why this is, because wait, what? Oh, this should be 0. Whoops, sorry. But basically, this is we're saying the base case where if there are no numbers left, then the longest ending here is 0, but there's one case where you end on here, right? So so that's my base case. So now we do a for index x in nums, or enumerate nums, and and now that I think from the last contest or yesterday's thing, you can actually choose to start variable, which I'll name that. So then index will start at 1 index instead of 0 index. So that's kind of nice. And then now we go for I don't know, previous index, say. I'm like mixing notations. In this case, I'll just do something like this. Previous in range from 0 to index, right? I mean, I know that you don't have to do the 0, but I just want to be a little bit explicit. But let's set up the base case for this particular thing, which is the longest ending on index of index is equal to 1, because you can always end on this current number, right? You could just have a longest increasing subsequence of just 1, and then the count is going to be also 1, because there's only one way to do it. And then now we kind of draw the graph a little bit, the implicit graph, where, okay, if the nums of index, which is x, I guess, but it doesn't really matter, is greater than or equal to, in this case, nums of previous index, that means that there's an edge, and then now we can do the longest path thing. So then we check whether the longest is greater than. So if this thing is smaller than if this is smaller than this thing, the previous index plus 1, then we just set this to be true to this thing. There's a long, maybe I should have used shorter names, but this is for explanation purposes. And then index of this is equal to 1, right? And then now, in a second case, because we're carrying about count, so else if they're equal, that means that, what does that mean, right? This is maybe the trickier part, where if this relationship is equal, that means that, for example, looking at 7, it's looking at this and it goes, okay, there's a path that's 1, 2, 3, and this is 4, the 4th number in the sequence. Also looking at 4, it's looking at, well, 1, 2, 3, 4, the 4th number in the sequence. So then there are 2 ways to get there, right? So now we want to sum up all the equal ways of getting there. So we don't have to update this because it is already true because these are equal, but instead we want to count. Actually, this is wrong. What we should do is actually extend the previous thing, so it should be equal to this, right? And it may be that this is 1, but if, for example, if there are 2 ways to like, let's say, for example, giving this away, let's say we add like a 9 to it, or 9 to it. This 9 is going to connect to 7 because 7 has the biggest count, but you know, there's still 2 ways to get from 7 to 9, so that's going to be this instead. And then here we want to increment it by that count for the same reason. Okay, so now at the very end we just have to get now we just have to get the max of the, we could have also did a running count or something like that, but now we set the max is equal to 0, say, and then we go through the loop for index in range of n plus 1, so that we go for the entire array. Mx is equal to max of longest ending on index, subindex, or mx. Or you could write it as just this, right? And then now, so let's just say we have now the longest index in there, and then we can go through the loop again to see, okay, if longest ending on index of index is equal to max, that means that this means that there's a maximum, that ending on this index, there are count ending on index ways to end here, and this is the longest subsequence, right? So that's kind of what this means. So then we just have to keep track of a total count. Total is equal to 0, and then total plus or equal to count ending on index. And there you go. I hope this works. I mean, it should work. I do worry a little bit about running time, but yeah. And did I have some typos? Because there's a lot of typing on this one, so it's very possible there's a typo. And oh yeah, there's a small I instead. 913. This is why we keep our variable name short sometimes, or use an IDE so that it handles it for you. But okay. So, oh yeah, so in this case, because this is one index, we have to keep track of this -1. Also in this case, that this makes this 1. Yeah. Whoopsie daisies. I get confused about using 1 index and 0 index from time to time. That's why I try to be really careful. But yeah. Maybe I've solved the wrong problem. The number of the longest. Huh. Oh, okay. No, so I misread this, but I solved the right problem. And this is that the length of the longest continuous subsequence is 1 because it has to be strictly increasing. I just misread that part. But that makes it easier in that, I mean, not easy to fix because that just means that for this part, we just update it to be strictly greater than. Okay, so that looks good. I'm just going to put some additional testing. I think in theory, I also want a big case. Let's run these real fast first, just to see if I get roughly the right answer. And then now, what's it, 2000? Let's do this together. Let's do a 2000 thing together. That's 5, 10, 15, 20, 40, 60, 80, 100. 2, 3, 4, 5, 6, 7, 8, 9, 10. That's gonna be way too much to copy paste. Okay, fine. Still do it one more time. Do. Let's see. Let's see if this is fast enough. Okay, so this looks a little bit on the slow side, but still fast enough. So let's give it a go. Let's give it a spin and. Ooh! Oh, empty array. I guess that's fair. I think, to be honest, this is debatable, but okay, fine. Because you could say that there's one way to have, like, mathematically speaking, I actually wouldn't debate that a little bit, in that that's the number of ways to reach an empty sequence, but maybe that's fine as well. So we just have to do also, let's add it to the test case. Let's double check running it. I feel like that's a little bit of a gotcha case, but because mathematically, you could define it either way, I suppose. Cool. So yeah, so this is accepted. So the time again is going to be n squared because you could see these two for loops going from 0 to n, relatively n choose 2, and then we have 2 linear loops. In terms of space, we use linear space, just the 2 arrays here. And yeah, so yeah, and you could actually upsolve this to n log n. The thing to notice is that can you solve it in n log n? I actually don't. There is the generic variation you could solve in n log n, but I don't know if you could do that and keep the count. I might have to double check on that one. But let me know what you think. Let me know how you solved this. Let me know if you did it okay. And I will see y'all tomorrow. Bye bye. Happy Halloween.